In this video, we're going to learn about exponential functions. So an exponential function is when we can write it as some constant times a number b raised to the x power. So the idea is that when our variable is in the exponent, that's going to be an exponential function. Now when you have exponential functions, they behave very differently than some of the ones we've seen before. Here's a table of values from one where we have the function 2 times 3 to the x. And if you look at this table of values here, every time we increase x by 1, we are multiplying our answer by 3. So if you think back to linear functions, when you have a table for a linear function, you're always adding by the same number. But for a table for an exponential function, you're always multiplying by the same number. One of the things that exponential functions are good for is modeling population growth, interest, and things like this, calculating compound interest and so on. So it's a very, very useful tool to have exponential functions. In this video, we're trying to get some of the basic properties down. So for our first example that we're going to work out, we've chose the function 2 to the x. So in this case, that c, the number in front, is really a 1, even if we don't write it. My base is a 2, and so on. Now we're going to make a table of values and use that to draw a graph here. I'm actually going to work from the bottom up because I can do 2 squared and get 4 pretty easily. 2 to the first is 2. Then 2 to the 0, we know that any number to the 0 power is 1. Then for the other two, if you have 2 to the negative 1, by the rules of exponents, that's 1 over 2 to the positive 1, or just 1/2, and I'll put it as a decimal there. And if you do 2 to the negative 2, it's going to be 1/4, or 0.25. And so if I try to sketch out here, I got 0, 1, 1, 2, 2, 4, negative 1/2. I have to be kind of just estimating here. And then if we kind of play connect the dots, you're going to look like this. And then if I were to ask you, what time do you actually get to the x-axis here? In fact, you're never going to, because if you imagine, taking half and then taking half again, you never actually get to 0. So it's going to get really, really close here, but it never actually crosses the x-axis. So for our default function here, and this works whether it's a base of 2 or any base, this is going to have no x-intercept. Now, of course, if you were to take this and shift it down or something, you can have an x-intercept, but the default graph is no x-intercept. There is a y-intercept, and that's going to be 0, 1 here. And again, it doesn't matter what your b is. Any number to the 0th power is 1. You are going to have a horizontal asymptote on the left side of y equal to 0. Right, got a nice horizontal asymptote over here. And on the right side, there's not going to be any horizontal asymptote. It's going to go all the way up to infinity up here. So this is a typical exponential graph. And in fact, if I didn't label what numbers the points were, this is the same shape for any default graph would be, as long as your base is a number bigger than 1. Now, going down here, the next example is I changed the base to being 0.4. And it turns out that if your base is a number smaller than 1, it flips the graph around here. So instead of it starting low and going high, it's going to start high and go low. It's going to be something like this here. Your horizontal asymptote is going to be on the right. And you can just check that by plugging in different x values, or you can put in a calculator or a computer program, whatever it may be. But just remember that when your base is bigger than 1, this is your generic shape here. And if your base is smaller than 1, it starts high and goes low. This other example here, we have 5 to the x minus 1, so it's a bigger number than 1 base, 5. However, we are subtracting 1 on the inside, and if you remember from the translations video, this means you're going to shift right 1. So instead of it going like up here, it's going to be, instead of 0, 1, it's going to be shifting right 1 there. It's going to look something like this. And so that point that was originally at 0, 1 is now over here at 1, 1. And if I wanted you to have more points, I could say, try to plug in another point here. And if you plug in 2, you'd get 5 just by plugging it in there. If you want to know the y-intercept, you plug in 0. And 0 will be 5 to the negative 1 power, or you can write that as 1/5, or as 0.2. So you really want to know the basic properties of how one side is going to be horizontal asymptote at 0, one side is going to go up to infinity. You need to know the x-intercept, that there's none of them, that there is a y-intercept, and the general shape, whether the base is bigger than 1 or the base is smaller than 1.